Hello, thank you for joining. My name is Pranav Panchal. Today we'll be going over the project submission for my machine learning project course that was led by John Reich Schneider and held by Coursera. Predicting parents' likelihood to open minor accounts. Our agenda we'll be going through. First, we'll go through the opportunity evaluation, and at the end, we'll go through some risks in production. Problem introduction. Without proper education, young adults must guess their way through critical financial choices, which could result them in making costly mistakes that impact their financial health and future. The reason we're trying to aim at this project to create the likelihood for parents to create a minor's account. We see this opportunity as a pretty feasible opportunity, as this is a very narrow and specific ask, making it a machine learning solution with the data available, which we'll go through in the next slide. The business value behind it. By identifying potential customers who are likely to open the accounts, financial institutes can help build good financial habits like savings before they become adults and build trust, which is a very key part within the financial industry, and also make them new customers and eventually increase the revenue at the same time. The data availability, it's pretty available. We do have there's existing data available for existing customers in the financial world. Let's go through some crisp DM business understanding. Our objective is to predict the likelihood. What the target user we'd like to approach is the parents with children aging from 12 to 18, given that we can train them, educate them, and coach them on financial health and education. The current state of this problem is today it's mainly focused around growing the customer base. What we like to do to understand the predictability is we like to use the F1 score, but we like to increase the accuracy by zero point zero 0.05, which is up to 0.75%. The outcome of this will be a report which will be provided to the marketing team for marketing campaign. We do see a constraint, which is data quality. The reason being is that we have quite a bit of data sets that we're factoring in, including age, income, financial history, demographics, and geographics and credit data, which are very, very different types of data sets. How do we plan to validate this solution? First, we are going to do the data processing and feature setting and creating new features, which we'll go through here. We're going to split the data in 80 to 20%, which 20 will be our test or cross-validation data that we call it. We will try to attempt creating new features, such as parent income, which will define income brackets, or owned vehicles, which will be comprised of credit information and financial transaction. Or we will also look for non-toddler transactions, where we will try to understand merchants that have children items, such as Babies R Us. And then we'll try to look at feature selections, which are parents' incomes with a mortgage of 3,500, and second feature would be parents with dogs insurance, likely to have children. How we will do this? We will iterate the training set and the test set using four approaches: logical regression, decision tree, random forest, gradient boosting, to determine the most viable solution. Our experimentation will consist of tuning hyperparameters, understanding the validation using the cross validation of the 20% that we have. End of the solution concept, what we want to do is to have a yes or a no. Is the parents likely willing to open up the account for their minor? So we would result to a classification. How did we do the model selection? We selected gradient boost binary classification. Reason behind gradient gives us really these three important things that help us build this model, which is ensemble methods, where we handle complex relationships of data between credit, transactional history, geographic, so on and so forth, and handles multiple mixed data types, which are consists of our data sets. And also we want to focus on feature importance, such as income brackets that we noted. Once we're at that point, what we are going to be doing for feature engineering is process the data and with what I've noted earlier. At the same time, we will conduct a joint development session with our data science and machine learning ops to build transparency for data processing and readiness and constraints for deployments in the future. At the end, our model evaluation, which is the gradient boost, will evaluate on F1 score. Why? Precision will be the total of true positive predictions of parents' likelihood of opening an account. And recall would be the actual positive, which will give us the highest accuracy. Is the parent likely to open the account? Yes or no? At the end, we will review what potential risk can happen in production. We can have model drift, where it's likely due to environment changes in data, or it could be changes within particular training data set that we may have not tested. But we do have to understand the model drift that can happen in production and relate those. The latency. How long does it take for the model to perform? Data quality, which we talked about a little earlier. Since we're getting multiple sets of data, we want to make sure the data quality is really well, because garbage in and garbage out. And then we have platform. Platform can have issues as well due to downstream and upstream impact. But what we would do is to understand or highlight these types of issues in production. We would apply a model monitoring for the model within the model deployment area. And thank you. My name is Pranav Panchal. Thank you for listening, and hope you enjoyed. And have a great day. Take care. Bye.